Students, this is question number 8. Let me write this question down. And AP is such that the first term is 6 and the 10th term is 19.5. Find the sum of 100 terms of AP. So this is first part. Now there is the second part. Second part is if A1, A2, A3, etc. is a GP such that the first term is 24 and the common ratio is 1/2. We have to find the sum to infinity of the GP. Okay, and it is denoted as S suffix G. Now, well, it is just denoted as S. Now, S suffix, we don't have to place that S suffix G. Now, we are also asked to find the sum to infinity. This is the complete GP. Now, we have to find the sum to infinity of the GP. So this one is going to be A1, A2, A3, etc. and this one is going to be A2, A4, etc. Only even terms. So two important evaluations have to be performed here. Now, having mentioned that, let me start up with the first part A. So this is a solution to part A. Now, given the AP with the first term, what is the first term? A is equal to 6, and we are also given the 10th term. A10 is 19.5. We are asked to find the sum of the 100th term. First, find the sum of the first 100 terms. It's not only the 100 term, we are asked to find the sum of the first 100 terms, right? Now, what I can do is, we will use this formula. We will use this formula. So what is the formula? Tn is equal to A plus n minus 1 into D. Now, we know the 100th term. We don't know the 100th term, but we know the 10th term. So we know A10 is equal to 19.5 and A is equal to 6. So if I were to take this as 1, so therefore 1 will be rewritten as, so the term is 19.5 is equal to first term 6 plus we are focusing on the 10th term, so 10 minus 1 into D. So 19.5 minus 6 is equal to 9 times D. Now this is going to be from 19.5, you take away 6. So that is going to give you 13.5. So 13.5 is equal to 9D. So D has to be calculated. So therefore D is equal to 13.5 divided by 9. So 9 divides 13 how many times? 1, you got 4 and 45. 9 divides 45 5 times. So therefore the value of D is 1.5. So that is what. Now we need to get the sum. As I mentioned to you, we have to find the sum of the first 100 terms. So for that there is a formula. So we will have to use the sum formula. So let me write that down. To get the sum of the first 100 terms, so we use Sn is equal to n over 2 of 2a plus n minus 1 into d. This is the formula we need to get. Now n is equal to 100. So this means s suffix 100 is equal to 100 divided by 2 times of, we have given the first term, which is 6, and we need 100 minus 1, and d is 1.5. We just got that value. 2 divides here 50 times. So S100 is equal to 50 times 2 times 6 is 12. 100 minus 1 is 99 multiplied with 1.5. So we have to multiply that 99 with 1.5. 9 5s are 45, 4 9 5s are 45, and 4 49, 9 9 5 9 9s are 18, 1 10 and 14. So you have a decimal point here. That would mean S100 is 50 times 12 plus 148.5. So you add 12, what do you get? You get a 10 and 160.5. So S100 is 50 times 160.5. So you multiply with 50. 5 is 25, 2, 33, and 5 ones are 5 and 8. And you have to add the 0. But after the decimal, there's a digit after the decimal. So this means S100 is equal to 8025. So this is the working, and this is the sum of the first 100 terms is 8025. So we have got that value. So we move on to the next part of the question. Now we are given A1, A2, A3 are in GP. So let me write that. Given A1, A2, etc. are in GP, and the first term is 24, and R is equal to 1 over 2. Now we are asked to find the sum to infinity of the GP. So I'm writing that statement, the sum to infinity of the GP is given as S is equal to A over 1 negative R. You got to write this condition for modulus of R less than 1. That condition is required. So this means 24 divided by 1 negative 1 over 2, which is nothing but 24 over 1 over 2. Because 1 negative 1 over 2 will give you 1 over 2. I flip it, I get 24 times 2, which is nothing but 48. So write the conclusion. Therefore, the sum to infinity of the given GP is 48. Now the next part, if the GP comprises of even terms, this means the GP has got A2, A4, A6, etc. So this in turn means to get A2, A1 has to be multiplied with R. But what is my A1? The first term is 24. So 24 you multiply by R, which will give you 12. So this in turn would mean my A2 is equal to 12. So therefore S is equal to, we need to get the sum to infinity, right? So A over 1 negative R with modulus of R less than 1. So we use this formula. So what is my A? My A is actually apparently over here. We need to utilize this quantity, 12. Okay. So 12 divided by 1 negative 1 over 2. That's R, which is 12 over 1 over 2. And that means 12 multiplied with 2, which is nothing but 24. So what have we got? We got the all important SE, the sum to infinity, right? So this means my S, in fact you can just place that SE there, suffix, because that's what the question has given us. So this means SE is equal to 24. So you can box that result and you can conclude the question. So we move on to the next one.